Hello and welcome. This tutorial shows how you can use Houdini Droplet Asset version 2 from VFXHOMELAND inside the Houdini, and as you can see, compared to the version 1, there are some new parameters here. Gravity and friction of the surface are self-explanatory. The next new parameter is tension. This parameter determines how easily droplets can leave the surface and drop. For example, if I decrease this number to 0.1, the droplets can easily leave the surface and drop down. And here, if I increase this number to 0.9 for example, the droplets like to stick on surface and slide on surface. Okay, let's use the default value for the tension. The next parameter is moving threshold, and this parameter helps to have more stable simulation, and the droplets move only if the amount of the displacement is greater than this number. The next parameter is collision resolution. This parameter is useful when you have separated collision objects, like in this case, the droplets can drop from the upper surface and collide with the lower surface. So if you decrease this number to the lower values, the droplets might pass the lower surface without collision, and if you increase this value too much, it can slow down your simulation. So I think the value of 5 is a good value for collision resolution, and also a value of 0.03 is a good value for moving threshold. The next parameter is inherit velocity, and if you animate the source, the particle can inherit the velocity when they drop. So for example, if I create a transform node and if I connect it to the sphere, and here let's choose polygon for the sphere, and here let's create a simple animation for the sphere, for example rotating around the y-axis, and let's use this expression $f multiplied by 2 or 3 and multiply this value by 180. Okay, and as you can see here, now we have this animation for the ball. So let's see the result here. And let's go to the top view. Here in the top view, you can see that the particles and the droplets can inherit the velocity from the source. And as you can see, because of this rotation, the droplets are shooting around this sphere. Okay, let's go to the frame 1 and let's bypass this transform node. The next new parameter is this option, points only. If you select this option, you will have only the points instead of the generated mesh, so you can handle the rest of the effect by yourself. You can create trails for the points, or you can generate mesh from these points, or you can use them as the sources for the particles. By enabling this option, you will have 2 point groups. One of them is dropping and the other one is moving, so the moving particles are in the moving group and the particles that are dropping are in the dropping group. So with the help of these two groups you can have access to the static points also. If you download and extract the zip file, you will have 2 more files and 2 more digital assets, and you can use them for creating same effect inside the pop network. And before using this digital asset inside the dop network, let's create a pop droplet source which creates sources for the particles. So here there are 2 options for changing the number of moving particles and static particles. Let's decrease this number to 20 and let's decrease the number of static particles to 300. And here there is an option for choosing between 2 methods of distributing points on the surface. Okay, and here now we are ready to create a pop network and connect this source to the dop network. Okay, here we have to create a static solver, and we need to create a static object. Let's merge the static solver using the merge node, and as the subpath let's select the sphere object. Also let's select the pop solver node and increase the maximum substeps to 2, and in the collision behavior tab let's enable add heat attributes. And also we need to generate particles only at frame 1, so let's go to the birth tab and let's use an expression like $f equal to 1, so it generates only particles at the first frame. And as the source and emission type, let's select all points. Okay, and here we can use the pop droplet solver node, and let's connect it to the source node. And here let's select the pop object, and for now let's decrease the bounce values and also the dynamic friction, and also let's increase the uniform divisions for the collision object. So let's increase it to, for example, 50. And here of course we need a gravity node, and I think that's all. Now we can run and see the simulation. Oops. And of course here you have to select the source for the pop solver node. So let's select the pop droplet source that we created before. Here there are 3 parameters for controlling the movement of particles: moving resolution, maximum size, which is the maximum size of each droplet, same as the droplet solver version 1 and version 2 that I talk about in the previous section. And also here we have tension parameter. It has the same effect as the previous tension inside the Droplet Solver version 2. Okay, and let's play the simulation and see the result. And here, let me disable this guide option to see only the particles, and also here. And let's play the simulation again. Okay, and you can see now we have the same effect inside the pop network. And also please note that now you have, for example, if I create a pop color node, here you have different groups of particles, the dropping particles, and I'm not sure if you can see this or not, the dropping particles, the moving particles, and the stick particles, and the stuck particles. And you can use these groups to apply different forces and different solvers and change the overall look of the simulation. Here, for example, if I create a pop wind node, and let's apply it to the, for example, dropping particles. Okay, let's increase the amplitude for the noise, and let's decrease the attenuation, and let's play the simulation again. And now you can see the pop wind nodes change the movement of the dropping particles. The other thing is that when you creating the source using the pop droplet source node, it creates P scale attribute for the points, and each point has a random number for the random value for the P scale. So if you are not happy with that numbers, you can create an attribute and call it P scale and change it, or you can simply add pop property node here and change the uniform scale, friction, and dynamic friction, and other attributes of the particles. Okay, that's all for the Droplet Asset version 2. I hope you like it, and I hope to see interesting simulations using this digital asset from you. Thank you for watching this tutorial, and I hope to see you in the next tutorial.